SCROA.
This is SC. Go ahead, ROA.
Confirm recovery area C state is conducive to recovery ops.
C state is conducive. Recovery is green.
Copy. Check 175.
RC, this is SRPO on 1.
RC's on. Go ahead, SRPO.
Yeah, could you just give us a track report from that last test rocket?
Yeah, and this RPO, this is RC. All radars report good track on test rockets.
Copy that. Thank you.
2D, this PM on 1. Could you give us a status check with VACAPE's clearance and initial contact with FAA? TD, this PM on 1. Can we check 176?
Check item 176. Good morning from the NASA Wallops Flight Facility in Virginia. We're counting down this morning for the launch of a Black Brant 9 suborbital sounding rocket carrying the Aspire payload. So far this morning, the countdown has progressed smoothly. We're working no issues. At 6 a.m., the range safety officer reported that winds are looking good for launch this morning. And so we are not expecting any issues as far as the weather is concerned for this morning's launch. Launch time this morning is targeted for 6:45 a.m. with a launch window that extends, if needed, to 10:15 a.m. Eastern Time. With us this morning is Gregory Villar. He is with the Aspire project out of the Jet Propulsion Laboratory out of California. So he's traveled all the way across the country, got up nice and early this morning to be with us. Good morning, Gregory.
Keith, good morning. I'm very excited to be here today, and I'm sure that's why we have millions of other space geeks out there watching this exciting launch.
Well, we hope so. What exactly is the Aspire mission? Why are we here today?
That's a very good question, Keith. So ASPIRE is actually an acronym. You know, NASA loves their acronyms. And that stands for the Advanced Supersonic Parachute Inflation Research and Experiments. And so this project was established to investigate the physics of supersonic inflation of parachutes, specifically the disk gap band. Really, the goal of this program is to expose two candidate parachute designs, which could be used for future Mars missions, to a supersonic inflation environment by launching them on sounding rockets out of NASA Wallops. So the goal of today's test is not about whether parachutes can open smoothly, but the goal of today is to get the test hardware to the appropriate test conditions. So that means, does the Aspire payload reach the right altitude, the correct vehicle attitude, which is its orientation, and the proper speed?
Okay, so you guys have come all the way from California, and of course there are other launch sites there on the West Coast. Why did you come all the way out here to Wallops for the launch?
Well, I'm sure if I did a Yelp search on sounding rockets, Wallops would definitely come up at the very top, and that's exactly why we're here today. Wallops is the best in the business, right? Wallops is the home of NASA's sounding rocket program, and you guys have decades of experience in successfully executing sounding rocket missions. We know that everyone at Wallops is very enthusiastic and dedicated and has the necessary expertise that we need for such a project. But more specifically, you know, Wallops has a considerable amount of experience with the Terrier Black Brant, which is the rocket configuration that will be carrying our payload today.
Okay, so the idea here is that eventually we'll be testing the parachute. You know, people see parachutes all the time. Skydivers, you see cargoes dropped out of airplanes. Why can't you guys just adapt one of those parachutes for what y'all are looking at?
Right. So that's a great question. So our parachute is specifically tailored for supersonic flight in the environments of a Martian atmosphere. So kind of the first thing to keep in mind here is that our parachute needs to be really big because the atmosphere on some planet like Mars has very low density. So the Aspire parachute is actually about 10 to 20 times bigger than a typical skydiving parachute. So when you think about it, with our parachute fully inflated, it is about 50 feet across wide. So for comparison, Justin Bieber is actually 5'9", and so if you stacked up 9 Justin Biebers, that would be kind of the width of our inflated parachute. Another difference we have is the inflation time. So the Aspire's parachute will be deployed at supersonic conditions, and this will cause the parachute to inflate much faster than skydiving conditions. So our inflation time is about half a second, but when you're skydiving, generally that takes about a few seconds to inflate the parachute.
Okay, so what exactly, you know, you're going to develop this supersonic parachute. What kind of a mission would it be used for?
So this parachute would, again, you know, we wouldn't use this for human skydivers, but this kind of parachute would be used for future Mars missions that would require landing really large payloads on the order of 2,000 pounds or more.
Okay, quite large. So I know that JPL and Wallops teams have been working on the Aspire project here for now almost 2 years. Is this a one-off mission, or are there several planned that, you know, everything will be learned a little bit and then we go from there?
Right. So yeah, as you mentioned, we've been working on this project for a while, and you know, I'm very excited today for this launch, and I'm sure a lot of my friends who are working on this project and everyone else is very excited. But we currently have up to 6 tests planned, but this first flight is actually a shakeout of the test architecture. It's important to note that in this configuration, the Terrier Black Brant, our payload is actually the largest in terms of diameter, and also the heaviest payload that has ever been on this configuration. So we're going to get a lot of great data from this flight.
So you mentioned, you know, that it's a large payload, obviously. If you're watching on the screen, it's obviously a little bit different shape than most sounding rocket payloads, which tend to be pretty much cylindrical. This one's a little bit what we call bulbous, so it does come out there in the middle. Can you describe a little bit about the payload? Why is it shaped that way, or obviously it's a different color, but yeah, if you could describe a little bit about the payload itself.
Sure, no problem. Well, the first thing people might notice, probably from the articles, but right now the the light's not too heavy on the rocket, but it is actually the color purple, like Barney the dinosaur. And the reason why it's purple is because out of all the colors we have to choose from, we think that purple will be the easiest to spot when we are recovering our payload. But in addition to that, the payload section is composed of several other aspects. First, we have ballast mass, so that helps us reach conditions that we need for our flights. There's also some buoyancy foam that we have in the payload so that it stays afloat for recovery. We also have a few systems. We have the telemetry system, which is kind of sending us data back during the flights. We have an attitude control system, which helps us kind of stabilize us during our flights. There's also D-spin hardware. As we're going up through the rocket, we're actually spin stabilized at about 4 hertz. So when we get up there, we need to kind of de-spin ourselves. And then there's the experiment section, which is delivered essentially by the Aspire project. And that consists of a mortar tube. The mortar tube houses our parachute, which is also in the experiment section. And we have an instrumentation ring. So the instrumentation ring has a bunch of cameras and load pins for us to measure loads. The parachute has 80 suspension lines attached to 3 bridles attached to 1 instrumentation ring. That's 1 ring to take images, 1 ring to read loads, 1 ring to measure it all.
And for all the Lord of the Ring geeks out there, you may have caught some of the analogies that were just mentioned there. Okay, so we're still counting down. We're coming up on T-minus 17 minutes and counting for the launch this morning at 6:45. Sounding rockets are, quite fast. The basic flight profile this morning is, as Gregory mentioned, we have a Terrier Black Brant, also called a Black Brant 9, so it's a 2-stage vehicle. It's all solid fuels. Once we ignite, we have what we call spin motors that are on the vehicle. So as soon as the vehicle extends off the pad, at about 1.1 seconds, the spin motors will ignite, and that will help spin the rocket and help stabilize it so it flies straight and narrow. Very similar to if you ever seen a slow motion shot of an arrow flying. The fins on an arrow are canted, and the arrow will actually spin as it flies through the air. And so as we mentioned, we have a D-spin system on the payload, so that will slow down or basically stop the payload from spinning when we get ready to do the test. So the first stage Terrier motor will burn out at 5.2 seconds after launch. At this point, it will only be 0.43 miles altitude out over the Atlantic. The second stage Black Brant then ignites at 8 seconds after ignition. At this point, it's 0.93 miles altitude at 35.5 seconds. The Brant will burn out at 10.35 miles. This particular vehicle, unlike other sounding rockets, will not be flying that high today. At about 2 minutes into flight, it will only be at 31.55 miles altitude. But it will be obviously high enough in order to test the systems out and possibly do a parachute test. So it's a very short flight this morning, and hopefully things will go. Next, coming up at T-minus 12 minutes, we will have the final poll to make sure that all the supporting systems, everybody's ready to go for launch. So again, we've just passed the T-minus 15-minute mark, so we should have that poll in about 3 minutes. So this is Wallops Range Control.
TDR, Zone 1, I have impact area status.
Go ahead, ma'am.
We currently have a green range. Our supporting aircraft are going to be vectoring to the northwest at about T-minus 10 minutes. We are good with our hazard areas there within limits. Safety's green at this time.
Copy. Check 177.
And that was the range safety officer reporting that we do have a green range, that the area in the Atlantic Ocean where the components of the rocket would be falling, we are reporting that no boats are within that hazard area. So we appreciate all the support from the mariners this morning.
PM.
If you have no hold, do you have permission to begin the terminal count?
Copy that. Thank you, sir. Check 178, 179.
All this is ROA. This is NRW 5765, Terrier MK70, Black Brant, launching from pad 250K launcher with effective launcher settings of azimuth 105.0 and elevation 79.9. Please stand by for station checks. All stations should announce status as green or red on channel 1. RC,
RC is green.
MNO,
MNO green.
LPM,
LPM is green.
PLC,
Green.
ACS,
Green.
PTM,
PTM is green.
Turn,
Turn is green.
MM,
MM green.
SC,
SE is green.
SRPO,
SRPO is green.
RSO, RSO is green. PM,
PM's green.
Arrow,
Arrow's green.
Experiment,
Experiment's green.
PI,
PI is green.
JPL,
JPL is green.
and TD.
TD's green. All stations are responsible for reviewing the go-no-go criteria listed in MOD. Only stations annotated with an asterisk in previous step are permitted to call a hold. All the sites should report red. Check 181.
RSO, ROA. RSO. Provide pad 250K launcher initial wind waiting settings. Roger. Settings are actuals, azimuth 112.0, elevation 80.1. LCROA.
Healthy go.
Set 50K launcher to initial wind waiting settings of azimuth 112.0, elevation 80.1.
Copy. In work.
This morning's launch is expected to be visible only in the Wallops area.
ROALC, launcher now set to azimuth 112.0, elevation 80.1.
Copy. Check 182, 183.
And if you're in the Wallops area and you're listening in on NASA TV or also on our Ustream site, there is a short delay. Can range anywhere from 15 to 30 seconds. So take that into account if you want to go out and see the launch.
Ten minutes and counting. Check 184.
ACS check 188.
PLC check 185.
MNO set ground station levels and confirm and start recorders and strip charts.
This MNO, step 186, ground levels confirmed, 187, data recorders and strip charts on.
Copy that. Thank you, sir. MNOs record signal strength deviation for TM1, verify nominal.
PTM check 190. Experiment check 191.
PM, this is M&L. Links recorded. Confirm nominal.
PLC check 192.
PM, this is M&L. Step 189. Check. Links recorded. Confirm nominal.
ACS check 193. PTM check 194.
RC interrogate transponder, verify good code.
Copy and work. And PM, this is RC check 195.
ACS check 197. PTM check 196. ACS check 198.
PLC check 199200.
PTM check 201.
PLC check 202.
Experiment check 203.
PLC check 204.
Experiment check 205.
I'm going to record signal strength deviation for TM2 and 3, verify nominal.
ACS check 207.
PM, this is M&L. Check 206. Confirm nominal.
RSO, ROA.
RSO.
Provide final wind weighting settings.
Roger. No change in final wind weighting settings. Actuals, azimuth 112.0. Elevation 80.1.
Copy. LCROA.
LC go.
There are no change in wind weighting settings. azimuth 112.0, elevation 80.1.
LC copies confirming those settings on the launcher.
Check 208, 209.
Aero check 210.
PLC check 211.
System's currently being switched over
ACS
to
check
internal
212.
power.
PLC check 216, 217.
RC interrogate transponder, verify good code. M&O verify no change in signal strength deviation for all.
ACS check 213.
PMS is M&O, no change on internal power. Check 215.
NPN is RC, check 214.
ACS check 218.
Check 219.
Turn check 220. PLC check 221. PLC check 223, 224, 225, 226. PTM check 227, check 228. Experiment check 229er. ACS check 222.
All confirmed go status, PLC,
Go.
PPM,
Go.
ACS,
Go.
turn,
1 minute.
Go.
JPL,
Check
Go.
230.
MM,
Go.
check 231.
We're go for launch. Coming up on 45 seconds.
Booster arm.
T-minus 28 seconds.
ACS check 232.
Minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, mark.
Currently on second stage burn. On the screen, you can see the performance of the vehicle at this time, flying straight and narrow, from the intended path.
The payload has separated from the rocket and is now on a trajectory to approach its test conditions. These test conditions are reached at a designated altitude, at the right velocity, and the correct vehicle attitude. So we received confirmation that the payload has reached its targeted conditions, and this marks the end of the test. Now, even though the deployment of the payload was the main objective of this test, we wanted to see if we can get extra parachute data, and we actually just received telemetry indicating that the parachute has deployed as expected. So the Aspire team is now deploying recovery boats to converge on the anticipated splashdown location so that we can retrieve all the valuable data that we have that's on the vehicle, which includes data about the deployment of the payload and also bonus data about the parachute inflation.
So next steps for this morning's launch, as Gregory mentioned, the payload will be descending and impacting into the Atlantic Ocean, where we will have a recovery boat with, I believe it's with the Virginia Institute of Marine Sciences, is helping us out this morning. They'll be recovering the payload. We'll come back here to Wallops, and there is onboard data on board, and so they'll be wanting to take a look at that data and preparing for the next flight. Right now we're looking at a no earlier date of the next test flight would be December, and so we'll see based on the data that we receive and preparations, that's what we're targeting. So from Wallops, that's it for this morning's launch. The next launch from Wallops is Orbital ATK's Antares rocket, carrying the Cygnus spacecraft with supplies and experiments to the International Space Station. That launch is currently targeted for November the 10th. So, everyone here at the NASA's Wallops Flight Facility and the Jet Propulsion Laboratory, thank you for tuning in this morning, and have a good day.